Hello and welcome to our fourth video on Pythagoras and Trigonometry. I'm Mr. Chowdhury and today we're going to be looking at using trigonometry to find a missing side. Now if you haven't already, I suggest you go and watch our video on the introduction to trigonometry and where the ratios come from before you come and watch this one. Just a quick reminder for those of you who have watched that video but may have forgotten a bit, the key component to trigonometry is that angle that we are given. We're still working in right angle triangles just like we were in Pythagoras. But the key thing here is that we understand that the angle we are given is what controls the ratio. The ratios will stay the same if the angle stays the same, regardless of the size of the triangle. And that's what we're going to explore here to begin with. So this is our first triangle that we've got here. This is our second triangle that we've got. What's happened from first triangle to second triangle? If we look, we are given the hypotenuse of both. What's happened between the first triangle and the second triangle? Pause the video and have a think. Okay, so if you said it's been increased by a scale factor of 3, you're correct. So it's been made 3 times bigger. The hypotenuse has been made 3 times bigger. And because of the geometry of triangles, we know that each side has also been made 3 times bigger because we've increased it by a scale factor of 3. Now what we can see is that the ratios haven't changed, and I'll show you what I mean. So the first thing we're going to do is label both triangles, right? Hypotenuse, opposite, adjacent, with regards to the angle that we're given. So hypotenuse, as you can see, is opposite the right angle. The opposite is opposite the angle we're given, and the adjacent is next to the angle we're given. Similarly, the other one's been labeled in the exact same manner. Now, if we look at the ratio between the opposite and the hypotenuse, the opposite divided by the hypotenuse gives us a half. Now, if we look at the second triangle, which is 3 times bigger, bear in mind, 3 times bigger, the angle hasn't changed, but the size of this triangle is 3 times bigger, we can see this, that our ratio is still a half. And that shows us that for any triangle where we have a 30-degree angle and a right angle, for any right angle triangle with a 30-degree angle in it, we will end up with a half if we divide the opposite by the hypotenuse. That ratio will not change. Right, we'll try another one. What's happened between these two triangles? Pause the video and have a go. So we can see that if we look at the two hypotenuses, they have been made 10 times bigger. So the hypotenuse in the first triangle was 1, hypotenuse in the second triangle is 10. So that means that each of the sides was made 10 times bigger. Right? The angle, however, the 30-degree angle has stayed the same. And remember, we said that trigonometry, the ratios are controlled by the size of that angle. So once again, we can check the ratios and see that they haven't changed. So this time, we're going to label the triangles, but this time we're going to be looking at the adjacent divided by the hypotenuse. So on our first triangle, if I do the adjacent divided by the hypotenuse, I get this ratio. Similarly, if I do it to the other triangle, I get the exact same ratio. So what does that tell us? How can that help us? Well, the key thing to do is notice the values that we have on our first triangle for the opposite and the adjacent. The values that we have in our first triangle for the opposite and the adjacent. Now these values are really important because we know that the adjacent divided by the hypotenuse is cos. We know that from our previous video. So if we pop cos 30 in our calculator, we get 0.866, which is the value of the adjacent on this left-hand triangle. We can see the adjacent is 0.866. Similarly, if you pop in sine 30 on your calculator, you'll get a half, which is the value of the opposite in this triangle. This means that if I have a triangle with hypotenuse 1 and an angle, the opposite to that angle will always be sine of theta, and the adjacent to that angle will always be cos of theta. So once again, what's happening here? What's happened between our first triangle and our second triangle? And if we know that information, how can we work out the opposite and the adjacent? Pause the video, have a think. So we know that the hypotenuse has been made 5 times bigger. That means we're going to have to make each of the sides 5 times bigger. So we'll end up with 5 lots of sine theta and 5 lots of cos theta, similar to what we did before where we made it 10 times bigger, we just multiplied each of the sides by 10. What about in this example? What's happened to get from this first triangle to the second triangle? What's happened? Pause the video, have a think. Well, similar to the last one, this time we multiplied by 7 instead of 5. So we get 7 lots of sine theta and 7 lots of cos theta. So we can start to generalize. So the pattern that we can see is that if whatever we multiply this 1 by, when we increase the size of our triangle, we have to multiply the sine theta and the cos theta, the other two sides, by the same value. So if I've gone from 1 to h, what have I multiplied by? Well, I've multiplied by h. So that means the opposite of this triangle becomes h times sine theta, and the adjacent to this triangle becomes h times cos theta. So we've just generalized how we can use trigonometry to find missing sides. Okay, so let's summarize everything so everything's neat and in one place, so you know exactly what we've learned from doing our 2 videos on trigonometry, right? So the first thing that we need to remember is our mnemonic, our so, ka, toa. That helps us remember the ratios, the names of the ratios, and which sides they are working with. The other thing we need to remember is how to label a triangle with regards to an angle. How do we label a triangle with hypotenuse, opposite, adjacent? What are the key things to remember? Well, the hypotenuse is opposite the right angle, always. The opposite is opposite the angle, always. And the adjacent is the one we fill in last. The other thing we need to remember is how we can write the ratios. So we've got sine theta is equal to opposite divided by hypotenuse. Cos theta is equal to adjacent divided by hypotenuse. Tan theta is equal to opposite divided by adjacent. Now you may be saying, well, Mr. Chowdhury, this doesn't link to anything we've done today. Well, it does, and this is how. So if we take the ratios we already have, and start to manipulate them, you can see the way they link to the triangles we worked in earlier on today. So let's have a look at manipulating these ratios. So we're going to manipulate sine theta. So we know that sine theta is equal to the opposite divided by the hypotenuse. That's what sine theta is. If we multiply both sides by the hypotenuse, we end up with hypotenuse times sine theta equals the opposite. And that was exactly what we had in our triangle earlier on. We said that the opposite of our triangle was h times sine theta. And we worked that out by adapting and looking for patterns in our right angle triangles. Similarly, it works the same for cosine. Once again, it works the same for cosine. We can see that h times cos theta is equal to the adjacent, and the same for tan, that adjacent times cos theta is equal to opposite. And this is how we can manipulate the formulas however we like. We can manipulate these ratios however we like to try and find whatever we need to find. So before we move on, here's everything on one page, so you can screen grab this, you can copy it onto some paper, you can have this as your little trigonometry ratios cheat sheet whenever you need it. It's all here. So pause the video, take a screen grab, pause the video, copy this down. Okay, so we haven't answered any questions yet. That's what you're probably asking yourself. So here's what I'm going to do. I'm giving you 2 sets of working. I'm going to give you 2 sets of working. What I'd like you to do is similar to what we did in the Pythagoras video, is tell me what's the same and what's different. And once you've done that, annotate the working for why you think each step has been done. So pause the video and have a go at that. So before we start doing any annotations, let's look at these 2 questions and see what's the same. Well, we can see that they are both in the same orientation, and we can see that the angle given is exactly the same. Both of them have a 50-degree angle in them, right? On the question on the right, we're missing the hypotenuse. On the question on the left, we're missing the opposite, right? We'll follow the working on the right. We follow the working, and we can see that the hypotenuse is equal to 12, which is exactly the same as the hypotenuse on the question on the left. And if we follow the working on the left, we can see that the opposite is equal to 9.2, which is exactly the same as the opposite on the right. So that tells us that both of these triangles are the exact same. So both of the triangles are same, but the working is different because on the left hand side, we're looking for a missing opposite, And on the right hand side, we're looking for a missing hypotenuse. Right? So now let's try and annotate these questions. Let's try and annotate this question. Pause the video, have a go at annotating it, and then I will go through it for you. Okay, so let's go through these two questions. Let's have a look at these two questions and annotate the working. So the first thing that they've done is that both triangles have been labelled. They've labelled them hypotenuse, opposite, adjacent with respect to the 50 degrees that we have. The next thing that they've done is decided which ratio to use. Should we use sine? Should we use cosine? Should we use tangent? Right? That's what they've done next. The third thing that they've done is substitute in the values that they have. They've substituted the values that they have. The next step has been that they've rearranged to make x the subject. Now, on the left-hand side, the rearrangement is super easy because they just multiplied both sides by 12 to rearrange it. So then multiplying both sides by 12 makes x the subject of this equation. However, on the right-hand side, they've had to do two steps. They've had to multiply it by x first to remove x as the denominator here. So they multiplied both sides by x. And then they've had to divide both sides by sine 50 to make x the subject. That's the difference between these two. So then they calculate those two answers, they get some answers, and they round to get their final answer. So the key thing that we can take away from this is that if we're looking for an opposite or an adjacent, the rearranging is very simple. We only have to do one step. Whereas if we're looking for the hypotenuse, the rearranging is slightly more difficult. We have to do two steps. So what we're going to do is we're going to answer some questions together and then let you go off and practice. So before we do that, we just need to become familiar with our calculator. On our calculator, the sine, cos and tan button are there, located there. If you have a different calculator, just have a look. They're usually near the top, so away from the numbers. It just says sine, cos and tan. They're usually next to each other. Right? Once you've located your sine, cos and tan, here's your first question. Have a go at doing it, and then we will go through it. Have a go at doing this, and then we will go through it. Right, so let's go through this question together. So the key thing that we need to remember, the first step when answering trigonometry questions is always going to be to label the triangle. Just like it was when we did Pythagoras, we should always label the triangle. So here's my right angle. I label my hypotenuse as 12. Here's my angle. I label the opposite, and then I label the adjacent. So I've labeled my triangle: hypotenuse, opposite, adjacent. Always the first thing we do. The next thing we should do is circle what we have. So I've got my hypotenuse, I've got the 12, and I've got my angle, and then I circle what I need. I need the x. I don't care about the opposite in this question. Don't care. Doesn't need to be there. The things that I care about are the things that I've circled. I care about the hypotenuse, which is 12. I care about the angle, which is 50. And I care about the missing side that I'm looking for, which is the adjacent x. Right? Then I need to decide which of the ratios to use. So I don't care about the opposite, so I'm going to ignore it. I need to look at these ratios and ask myself which one has the adjacent and the hypotenuse in. Which one has the adjacent and hypotenuse in? Now there's only one ratio with adjacent and hypotenuse, and that's cos, or ka, in our mnemonic. So, ka, toa. So now that I've done that, I can write down what ka looks like. So that's cos theta is equal to adjacent over hypotenuse. Adjacent over hypotenuse is cos theta. I then substitute my values in. I've got cos 50 is equal to x over 12. I then need to think, right, how do I make x the subject of this equation? How do I make x the subject of this equation? And that's very simple here. All I need to do is multiply both sides by 12. So I end up with 12 times cos 50 is equal to x. 12 times cos 50 is equal to x. Now I can just pop that on my calculator. Now there's a bunch of ways you can do it, but here are some of the ways you can do it. You can write 12 times cos 50 and press equals. I can write 12 cos 50 and press equals because I don't need to put the multiplication in. I can also write cos 50 times 12. The key thing to view here is that if I have the 12 before the cos 50, I don't need to close my bracket. Now, if I have the cos before the 12, if I've got cos 50 before the 12, I do need to clear my bracket. The other thing to notice that's really important is I've got a small d on my calculator. Now, if that says R, you will get a different answer, because that's because your calculator is set in radians. We want our calculator set in degrees because we're working in degrees. So you need to make sure your calculator is set in degrees before you do any trigonometry questions. Once I've done that and I've calculated the value, I get my number and then I just round it to one decimal place in this example, and that's my answer. So we'll do one more. Here's another one for you to try. Pause the video, have a go at that. Okay, so let's answer this question together then. Let's answer this question together. So the first thing we're going to do is label our triangle. Hypotenuse, opposite, adjacent. Hypotenuse, opposite the right angle. Opposite the angle given. Adjacent, the one that's left over. The next thing you're going to do is circle what we have. So I have 12 and I have 50. I have my adjacent and I have my angle. Then I circle what I want, which is my hypotenuse, which is x, the hypotenuse, the side I'm looking for. Once again, I don't care about the opposite. I then decide which ratio I want to use. So I will write down SOHCAHTOA, think which one of the ratios has adjacent and hypotenuse in it. Which ratio has adjacent and hypotenuse in it? That ratio is K, or cos is a ratio with adjacent and hypotenuse. So I just circle K so I know which one I need to use. I then write out the ratio. So cos theta is equal to adjacent divided by hypotenuse. Substitute in my values. So I've got my 12, I've got my x. Now I need to try and think, how do I rearrange this to make x the subject? Well, before, x was the numerator, but now x is the denominator. So I'm going to have to do two steps. So step one, I multiply both sides by x. So I get x times cos 50 equals 12. I still haven't got x as the subject, so I divide both sides by cos 50. So I get x is equal to 12 over cos 50. I can then calculate this, so I can put it in my calculator. I can put it in my calculator like this, where I just write it as a fraction. Or I can put it in my calculator like this, where I do 12 divided by cos 50. Notice I don't have to close the bracket here, whereas if I write it as a fraction, I have to close the bracket. Once I've done that, I can round it. In this question, I've rounded it to one significant figure, and I've got my answer. Now, hopefully, these two examples have helped you, so we know how to work out questions when we're looking for the hypotenuse. We know how to work out questions when we're looking for the opposite or adjacent. What I suggest you do now is go and watch Mr. Amoson's video to do some practice. If you're feeling super confident, go on Corbett Maths and Dr. Frost to do some questions on your own. Hopefully this has been helpful. Go off and be productive, and I'll see you in the next video.